If you've ever spent hours, or heck, even days, manually configuring VLANs and IP routes just to get a new firewall into your network, then you know the pain. It is slow, it's risky, and let's be honest, it's a huge bottleneck. Well, today, we're going to dive into how Cisco ACI's service graphs completely automate that process, turning a massive headache into a simple, repeatable policy.
So let's just start with the core challenge, right? Modern applications are anything but simple. Their traffic needs to navigate a very specific sequence of services. A firewall first, then a load balancer, maybe an SSL offloader after that. Manually stitching this service chain together is where everything gets messy. So how do we build this critical path for our apps without completely drowning in command line interfaces and risking human error every single time we make a change? All right, so here's what we're going to cover. We'll kick things off by really digging into the frustrations of traditional service chaining. Then, we'll introduce the service graph as ACI's really elegant solution. We're going to break down the two main ways it works, look at how ACI cleverly manages the actual devices, and then tie it all together with a real-world deployment workflow. You're going to want to stick around, because by the end of this, you'll see how this can totally transform your network operations. Okay, first up, let's really get a handle on the problem we're trying to solve here. Why was a completely new approach like this even necessary in the first place?
Think about it. In a traditional network, every time you want to insert a service, it's a major project. You are wrestling with VLANs, you're fighting with complex routing, and you're tweaking access control lists, all configured box by box. This isn't just slow, it's incredibly fragile. One little typo in a route map or an ACL can bring down a critical application. And in a world that demands speed and agility, this manual bottleneck just doesn't cut it anymore.
And this is where we turn the corner from the problem to the solution. Let's see how the policy-driven heart of Cisco ACI tackles this challenge head-on. First off, let's just lock in the terminology. A service chain is simply the required path for your traffic. I like to think of it like an assembly line. For a web application, traffic might first hit a firewall for a security check, then it moves on to the load balancer for distribution. It's that specific, ordered sequence of functions. Now, here's the real game changer. A service graph takes that logical assembly line and turns it into a reusable, automated template. So instead of configuring routes and VLANs and all that plumbing, you simply draw the service chain that you need. ACI then takes care of all the underlying network configuration automatically. This is a huge shift from that old box-by-box configuration to a more modern, intent-based approach to network it. And this slide gives us a really great visual breakdown. The whole concept is beautifully simple. You've got nodes, which represent your service functions, the firewall, the load balancer. And then you have connections, which act like virtual patch cables, defining the path between those nodes. You are literally visually drawing your service chain. So the really crucial point here is that a service graph is way more than just a diagram. It's a live policy object. The nodes are your services, the connections are the links between them. But the real magic happens when it's attached to a contract. The contract is what dictates exactly which traffic gets redirected through the service chain. It does this by linking together what ACI calls endpoint groups, or EPGs, which are really just logical buckets for your servers, like all my web servers or all my database servers. Okay, so we've defined our logical chain. But how does the traffic actually move through these physical and virtual appliances? ACI gives us two really powerful modes to work with here. The choice really boils down to this. Do you want your service device to be a Layer 3 router, or do you want it to be a transparent Layer 2 bridge? In go-to mode, which you can just think of as routed mode, the appliance is a gateway. Traffic is explicitly routed to it as its next hop. But in go-through mode, or transparent mode, the appliance is basically invisible to the endpoints. It's a bump in the wire that inspects traffic as it passes through, without changing the routing path at all. And this diagram just illustrates that difference perfectly. Take a look at the top diagram for go-to mode. You can clearly see the service device has IP addresses on its interfaces, right? It's acting like a router between two different subnets. Now look at the bottom diagram for go-through mode. There are no IP addresses on those data interfaces. It's simply acting as a transparent bridge, inspecting traffic as it flows between two segments. So we've covered the logical graph, and we've covered how the traffic flows. But what about the actual, the physical hardware, or the virtual appliances that are providing these services? How does ACI manage those? Well, this is another one of those key ideas that makes ACI so powerful. A concrete device is, well, it's exactly what it sounds like, a single physical firewall or a single virtual load balancer. But ACI also has this logical device object. This is basically a management container that represents a whole cluster of concrete devices, like an active standby firewall pair, and it lets you manage them as one single resilient unit.
This visual shows that concept perfectly. You define your policy, and you attach your service graph to that one logical device inside the APIC. That's the Application Policy Infrastructure Controller, the brain of the whole ACI fabric. The APIC then intelligently handles everything else. It applies that configuration to the underlying concrete devices, and it even manages things like failover for you. This makes high availability so much simpler. All right, time to put all the pieces together. We have all the concepts down, so now let's see how they translate into a practical, repeatable workflow to deploy a fully automated service chain from scratch. The process is actually incredibly logical when you break it down. First, you tell ACI about your appliance cluster by defining it as a logical device. Second, you create that reusable service graph template, drawing out the chain of functions. Third, you attach that template to a contract that sits between the applications that need it, your consumer and provider EPGs, and then finally, the fabric performs the magic. It renders that abstract policy into concrete network configuration, and it automatically picks an available appliance to handle the traffic. And this final diagram just synthesizes that entire workflow beautifully. You can see the device definition over on the right. You see the abstract graph template up at the top, and right in the middle, you can see that template being applied to the contract between the web and the app EPGs. And the result, down at the bottom, is a fully rendered, completely automated service chain, brought to life by the fabric itself. Ultimately, if you remember just one thing from all of this, let it be this. Service graphs are all about deep automation. They take one of the most complex, error-prone, and time-consuming jobs in networking, and they transform it into a simple, abstract, and really robust policy. And that's what frees up network teams to focus on what the applications need, instead of just the network plumbing. This shift from manual configuration to automated policy is profound. It isn't just about deploying firewalls faster. It's about enabling real business agility. It means you can roll out new applications in minutes, not weeks. It means your security policies get applied consistently every single time, which dramatically reduces risk. So the real question is, how are you going to leverage that power to accelerate your business and innovate faster than everyone else?